Today we're going to talk about literal equations. So in this first problem, we have P equals I R T. This is an example we did in class today, and we want to get T by itself. That's the variable we need to solve for. So in order to do that, first I need to think, how am I going to get T by itself? Well, if I look at this part right here, it's I multiplied by R, which is multiplied by T as well. So in order to get T by itself, I need to do the inverse of multiplication, which is division. So first, I'm going to divide both sides by I. When I divide both sides by I get P divided by I equals, now those i's, I divided by I is 1, so I'm just left with RT. Now again, R is multiplied by T, so what I need to do again is divide by R as well. So now I'm going to divide by R on both sides again. Now I have P divided by I divided by R. Now to simplify this fraction, when you divide a fraction by a fraction, what you have to do is multiply by the reciprocal. So I'm going to take P divided by I and multiply it by the reciprocal of R. There's a 1 underneath this R, so if I flip it over, that becomes 1 over R. And then I just multiply this fraction, so P times 1 is P, and I times R is IR. So now this is what the left-hand side, that's what this used to be right here. So all I did was take this and simplify it to look like this. So now I have P over IR, and that's going to equal T. And now T is by itself, which is what we wanted. Now if that's confusing, if you don't like this division by a fraction, the other way you can solve this problem, again we have P equals IRT. Now we know these are multiplied, and we know the inverse of multiplication is division. So since these are both multiplied, it's I times R, and all of that is multiplied by T, I can just divide the whole thing by I times R. And then divide this side by I times R. And now I times R divided by I times R is going to be a 1, because I'm basically taking IR divided by itself here, and anything divided by itself is 1. So now I have P over IR, and that equals T, which is what we had over here. So there's two ways we could have done that problem. Let's do another example. If we do number 2, which was also an example we did in your notes, we have A equals 2 times L plus W. Now what I can do first here is I can distribute this 2, because I know I'm taking 2 times all of this in parentheses, so I'm going to distribute, so A equals 2L plus 2W. Now we are trying to get W by itself, so in order to get W by itself, I need to get rid of this 2L. Well, this 2L is added to the 2W. The inverse of addition is subtraction, so I'm going to subtract 2L from both sides. 2L minus 2L is 0, and over here, these are not like terms. This has an A, this has an L, so they're not the same. So I have A minus 2L equals, that goes away, makes a 0, so then I just have 2W left. And now that 2 is multiplied onto the W. The inverse of multiplication is division, so I'm going to divide both sides by 2. So I have A minus 2L divided by 2, and that equals W. Now I need to simplify this, so I'm going to break this up into a fraction. So I have A divided by 2 minus 2L over 2. And now if you look, this 2 is going to divide, this 2 is going to divide by this 2. So I just get A divided by 2 minus L, because 2 divided by 2 is 1. So I'm just left with an L, and that equals W. Now we're going to do that problem a different way as well. So we have A equals 2 times L plus W. Again, we are multiplying. So since I'm multiplying the 2 onto all of this, kind of like how we did in number 1, we had I times R times T. 2 is multiplied by all of this, so to find the inverse of multiplication, we divide. So I'm just going to divide by 2 right away. So then I have A divided by 2 equals, well, 2 divided by 2 is 1, so that's going to go away, so I'm just left with L plus W. And now since I wanted W, L is added to the W. The inverse of addition is subtraction. So I have A over 2 minus L equals W, which matches that one as well. Alright, we'll do a couple more. Let me switch my paper here. Now we're going to do number 5, which is x plus y over 3 equals 5. Now we want to get x by itself. So in order to get x by itself, I need to get rid of this denominator in this fraction. Whenever you have a fraction, you need to get rid of the denominator first, so that'll be a lot easier to mess with just numerators. So this operation right here is division. A fraction is just a division problem. So I have x plus y divided by 3. Well, the inverse of division is multiplication, so I'm just going to multiply here. Both sides, of course. Well, again, these are inverses, so that's going to go away. So I'm just left with x plus y, and 5 times 3 is 15. Now I want to get x by itself. Y is added to the x, so now I'm just going to subtract it because that's the inverse. So x equals 15 minus y. We'll do one more problem. Let's do 14. This is a good one. This is from your worksheet that I handed out to you guys today, in case you haven't noticed. So R equals E over I, and we want to get I by itself. Well, again, we have a fraction, and even though the variable we want, which is I, is in the denominator, again, the best thing to do is to get rid of the denominator in order to have everything as numerators and then solve that way. So again, a fraction is just a division problem. So I have E divided by I. The inverse of division is multiplication, so I'm going to multiply both sides by I. Again, that's going to go away, so I'm just left with an E, and then I have I times R on the left here. Now I want I by itself, and I have multiplied it by R now, so in order to find the inverse of multiplication, we are going to divide by R on both sides. That goes away, so I equals E over R. And those are just a couple of literal equations that we did today.